the distance x from right hand. I'm defining x equals 0. This is x equal to L. Okay. Now it's asking to calculate the tension at a distance x here. Quite natural. Will there be tension? Yes, there will be tension. So what you do is like you just break up this. Can we break up things? This will be F and this will be tension. So now will all the parts of rope will accelerate, or only few parts will be at rest, or few will be in motion? All the parts of the rope will accelerate. No? What is the acceleration of this part? There will be the acceleration of this part also. Let the mass of this part be m1, let the mass of this be m2. Similar to two blocks one. Then let's calculate F minus T equal to m1a, T equal to m2a. What is lambda will define? It is m by L. F minus T. What is m1? Lambda into x will be the mass of this part of the rope. What is m2? Lambda into L minus x. What is lambda into L minus x? Mass of this part of the rope. That is what m2. Then adding up this, F is equal to lambda L into a. What is lambda L? Is ma only. Okay, now I got expression for acceleration. What is that? F by m. Sir, we already know net force by mass. Okay, well and good. If you are able to make such a very clean observation, well and good. Start directly from there. Let me substitute this in the equation for tension. T equal to m2a. m2 F by m. What is m2? I'll bring once again. Lambda L minus x. What is m? Lambda L. No. Put x equal to 0. What is the tension? Will be F. What force you applied? I'm going to recollect back what I said. With what force you pull the rope, there will be the tension. Not if the rope is accelerating. If the rope is accelerating, then definitely the tension at this end will be F. What about, sir, tension here? Will be 0, no? Put x equal to L. If you put x equal to L, what is the tension? Tension at this point is 0. With what force you pull the rope, that will be the tension everywhere. No, at the end where you are pulling, that will be this one. Sir, like I really want you to answer this question. Okay, you said. Okay, what about this? Now I am pulling this end with a constant force F. Rope is moving or at rest?
Rest.
This is at rest. What about this rope?
Moving.
This is moving. And now what do you say about tension?
Will it be equal to force?
I want really students to answer this. As anybody is free to answer this one.
Sir, will it be equal to the force?
I don't know, pa. You should answer. You want to become engineer? You should answer. Definitely at rest, no, this rope or rope will move.
Rest
Right,
only,
right,
sir.
sir. So tension
Will it
will
be a
be
test only? No, I think all are sure. No problem. This is okay. Fine. What about the tension?
equal to the force, sir.
Equal to the external force
Yes, sir,
applied.
equal to the force.
Everywhere.
Yes, sir.
Yes, sir.
Yes, sir.
Everywhere.
Yes, sir.
Yes, sir.
Ideal string means everywhere, sir.
Yes.
It is kept on smooth surface. Let it have a mass. No problem. Let it have a mass. No problem.
Sir, even also tension will be same everywhere.
Even also tension will be same everywhere. My question is tension. What happened to tension everywhere?
Sir, the other end is smooth.
What about?
The other end
Uh,
smooth. It is smooth.
are you not seeing wall connected to wall? Huh? Please understand question. I took rope. I connected to one end of the rope to the wall. The other end I'm pulling by a force F. Ground or horizontal surface, what will be that? Tension will be same at all points. Tension here. So if you choose A, B, C. So let's don't go for generalization. Sir, tell me one formula. I'll apply everywhere. Those days gone. You are in college. That you are in class 11. That you are taking for coaching for IIT, JEE mains, advanced, NEET, all the exams. So don't expect like one formula is there. Sir, tell me one formula. I'll apply everywhere. First of all, come out of that approach. Come out of that approach. There is a very wrong way of analyzing things. Still somebody will they'll message, sir, why don't you give us an idea so that we can solve all problem? How it's possible? I can just share some methods like, okay, if you come like this, so tomorrow they may ask in exam some new thing. You should know all these basics and you should apply it. Tension be same, equal to F. This little bit difficult. Okay, sir, like you side, okay, we'll accept. That's all. But sir, like still, can you justify your answer? You are giving like an answer. That's all. But where is the justification? Yes, really, some explanation is needed. Mere, I'm just writing condition. That's all. Tension will be same at all points. Why? Then what you should say? Go home. Or sorry, you are already at home. No? At home, buy one rope, tie to the window, pull it. Then you see tension everywhere. This should be the one standard reply from teacher. In spite of this, as we can explain. Now the same problem, let me show it in other way so that we can analyze easily such conditions. I will come back to again this diagram. So instead of this, let's our approach be of this one. So let the force be F. Here there's a tension, there's the X, then this will be dx. The tension here will be T, will be T, because I gave this method, no? On any small part, the tension should always act away from the body. So what is this small? There's a small element. On the small element, I have to show that. Then if I show T and T, okay, fine. Then what is the net force on the element? 0. Then how come it will move? So definitely, what do we expect tension? Where it should be more, on the right hand side of the element, or on the left hand side of the element? Yes, the tension should be T plus dt. Then only the net force non-zero, then only this element will accelerate. Otherwise, if you just write T and T, not justified. But okay, look at now. The very few best condition, or a very good condition is there. Altogether, as x increases, the tension is decreasing here, no? As x increases, the tension is decreasing, because x you are going to measure towards left, and as you move from left to right, the tension decreases. So therefore this will be dt is equal to dma, or if you are getting confusion, its best way of writing this equation is t plus dt minus t equal to dma. T get cancelled, so dt dma lambda. This will be very troublesome, but your mathematics has to come into picture. So why negative sign? Because as x increases, tension decreases, or dt by dx will be negative. Therefore I am bringing negative sign here. So further this dt equal to minus lambda. Let's go for limits. At t equal to 0, the tension, at x equal to 0, the tension must be equal to F. That's all. No, here what is the tension? Here it should be F.
Only, sir.
Then here it should be X. At X, let T be the tension.
Zeros.
So this will become T minus F equal to minus lambda A X minus 0. What is lambda? Lambda is m by L. What is x? X is f by m.
Sir, minus fx, fx by L.
Here negative sign I forgot.
Minus.
1 minus it should be. No, I think still my answer is correct, no?
Yes,
L
sir.
minus x by FL. I'll write it in that form. I'm going to show the complete description. This will be the other approach. Mathematical approach will help you a lot. Okay, now I can justify. Now I can justify it.
Sir, here this object is placed on the smooth surface or on the walls?
On the smooth surface, the same thing. Okay, you want that. And now can we justify our answer? You take small element, then everywhere T and T, it will cancel out. T. So net tension should be 0. No, the tension you have to break up like this way. This is the best method. You break up here.
Sir, you have substituted the limits, no, sir? dt.
Okay.
Sir, you have substituted limits for dt, no, sir?
Tension here. At x equals 0, tension is F, and at a distance x, the tension is T.
Oh, okay, sir. Okay, sir.
Now I can justify clear. I'll take small element. What should be the tension? Because what was the purpose? We have to justify this one, no? I'll do justify it now with this mathematical thing what we know it. This I think totally different one. I will. No, the same thing. I'm going to break it up. Tension at A is I need it. I'll break it up. Let's see. I'll pull this with a force F. Just only for our analysis purpose. So here what will happen? The tension will act here in this direction. Then what is the state of this element? Is at rest. This at point A. Then here tension will act in this way. Then what is the state of this? At rest. At rest means then F minus T should be 0. So T equal to F. Sorry, you similarly break up here also, we'll see it. Oh, we can't do. Yeah, I'll bring another one. Let's break up at C also. Then we'll see the. What is the net force on this? It is also at rest. Then air reaction also, let's find out. Let's see. What do we get? This is also at rest. Okay, are you getting now? We have to make observation. There's no other way. You have to make observations minutely.
The reaction must be equal and opposite, no, sir.
Reaction, okay, R equal to T.
Sir, but they are opposite, no, sir.
Let it be, no problem. That is what R is a reaction by the wall on the rope I'm showing. If that is the case, if you're getting confusion, I have to remove this. Okay?
Yes, sir.
Sir, can you scroll a little bit up, sir? Yes, sir. 1 minute, sir.
So getting the idea?
Yes, sir.
See, kinematics was easier, some equations, some mathematics, but here we should be more near to the physical world. That's why from the beginning, very first class, I was insisting it. The more you are aware of the physical world, the better, little bit easier, things are easier for you. You can gradually improve the things.